At this point, we're ready to talk about the Euclidean algorithm itself. So here the idea is that you want to compute the GCD of A and B. Just without loss of generality, assume A is bigger, because if it's not, you can just flip them. The GCD of A and B is the GCD of B and A, and so the GCD is symmetric in that sense. We're just going to assume that A is bigger. And what we're going to do is we're going to start off with A is equal to BQ plus R, and then we call it BQ naught plus R naught, where what we do is we use the division algorithm, where R naught is between 0 and B minus 1. And from the previous proposition, we know that the GCD of A and B is the same as the GCD of B and R naught. And so we're going to do this again. You're going to take R naught, divide that into B, and you're going to end up with a quotient of Q1 and a remainder of R1. You're going to do it again. R naught is R1 times Q2 plus R2. And what you're going to do is you're going to eventually get to a point where you're going to have RK is equal to RK plus 1, QK plus 2, plus RK plus 2. And then at the next step, you're going to have RK plus 1 equals RK plus 2, Q plus 0. And then what you're going to do is it turns out that this last non-zero remainder is the GCD of A and B. So in practice, let's use this algorithm to compute the GCD. So let's compute the GCD of 300 and 130. And so what we do is we take 300, 130 goes into 300 twice with a remainder of 40, and 40 goes into 130 3 times with a remainder of 10, and 10 goes into 40 4 times with a remainder of 0. And so it turns out that our last non-zero remainder, which is 10, is our GCD. So the GCD of 300 and 130 was 10, as we said. This is a very quick, very efficient algorithm. Let's do another one. Let's compute the greatest common divisor of, let's say, 57 and 117. Okay, so 57 and 117. Actually, let's make it a little bit more interesting. Let's say 57 and 129. Okay. 129 is the larger number, so I'm going to put that on the left. So I just automatically put the larger number on the left side of the equal sign. 57 goes into 129 twice. Now 2 times 57 is going to be 114. So that means that we're going to have 57 plus 15. Okay, and then we're going to do it again. And so 57, well, 15 goes into 57 3 times. So that's 45 with a remainder of 12. 12 goes into 15 once with a remainder of 3. And 3 goes into 12 4 times with a remainder of 0. So again, our last non-zero remainder is 3. So that implies that the GCD of 57 and 129 is 3.